Hi everybody, it's Mrs. Martello. Today we're going to look at operations with the radicals. We've already looked at multiplying and dividing. Today let's look at adding. So we're going to look at example 8, part A. We have 5 square root of 7 plus square root of 11 minus 8 square root of 7. Now, in order for us to be able to add these square roots together, they must have the same radicand. Remember that the number under the radical is the radicand. So the 7, the 11, and this 7 are the radicands. Since this first term has a radicand of 7 and the last term has a radicand of 7, that means that they can be combined together. This square root of 11 doesn't have a like term, so it's going to have to stay separate. So we are going to put the square root of 7s next to each other just using the commutative property. So I notice that these are like terms. Next, let's combine them. When we combine them, we only combine the numbers in front of the radicals. So that's the 5 and the negative 8. The radicands, the 7s, remain the same. So our next step is we're going to group the 5 minus 8 together, and then this radical 7 doesn't move or doesn't change. This radical 11 is still over here because it doesn't have a like term. Next, we can combine 5 minus 8 is negative 3, radical 7, and then plus radical 11, and that would be our final answer. Let's take a look at letter B. We have 10 square root of 5 plus square root of 20. Now, the radicand of the first one is 5, and the radicand of the second one is 20. Right now, they are not perfect squares. However, 20 does have a perfect square factor inside of it, so this square root of 20 can be simplified. Let's simplify the square root of 20. I can see that the biggest perfect square factor inside of 20 is 4. 4 times 5 would give me 20. Notice how the 10 square root of 5 stayed the same. Let's keep simplifying. So the square root of 4, the 4 is the perfect square. So I can put 4 in its own square root and put 5 separate. Now let's take the square root of 4 to give us 2 square root of 5. Notice how this 10 square root of 5 just stayed here the whole time because it could not be simplified. But look at now what we have. We have 10 square root of 5 plus 2 square root of 5. Now they have the same radicand, and now they can be added together. So let's add the numbers in front, the 10 and the 2. They will be added together. 10 plus 2 gives us 12 square root of 5. We are going to skip any example that has this cube root symbol in front. We're not going to do any cube roots. Let's look at some more examples. We're going to have Big Ideas explain it to us.
Simplify each expression. Part A, 3 times the square root of 15 plus 2 times the square root of 13 minus 7 times the square root of 15. First, use the commutative property of addition to rewrite the expression as 3 times the square root of 15 minus 7 times the square root of 15 plus 2 times the square root of 13. Then use the distributive property to write the expression as the quantity 3 minus 7 times the square root of 15 plus 2 times the square root of 13. Because 3 minus 7 equals negative 4, the expression simplifies to negative 4 times the square root of 15 plus 2 times the square root of 13. Part B, 5 times the square root of 7 plus the square root of 63. First factor using the greatest perfect square factor. Notice that the greatest perfect square factor of 63 is 9. So 5 times the square root of 7 plus the square root of 63 equals 5 times the square root of 7 plus the square root of the quantity 9 times 7. Then use the product property of square roots to rewrite the expression as 5 times the square root of 7 plus the square root of 9 times the square root of 7. Because the square root of 9 equals 3, the expression simplifies to 5 times the square root of 7 plus 3 times the square root of 7. Next, use the distributive property to write the expression as the quantity 5 plus 3 times the square root of 7. Because 5 plus 3 equals 8, the expression simplifies to 8 times the square root of 7.